Imagine flying a spacecraft directly into the sun and somehow surviving. Sounds impossible, right? Well, NASA actually did it. NASA's Parker solar probe just touched the sun, and what it found changes everything. On December 24, 2024, while millions of people were opening gifts, watching holidays, movies, and spending time with family, NASA was making history. A small spacecraft about the size of a car was racing towards the sun at an unbelievable speed of 430,000 miles per hour. That is the fastest any human-made object has ever traveled. And then suddenly it disappeared. No signals, no communication, no way to know if it will survive. For 2 days, scientists could only wait and hope. But when the spacecraft finally called home, it brought back something incredible. This is the amazing story of the Parker solar probe, the first spacecraft ever to fly through the sun's atmosphere. For thousands of years, humans have looked at the sun as something untouchable. Ancient civilizations worshipped it. Scientists studied it from afar, but nobody had ever gone inside its atmosphere. Until now, the Parker Solar Probe mission was designed to answer some of the biggest mysteries in solar science. And what it discovered is already changing our understanding of the sun and the entire solar system. The sun's biggest mystery. Most people think the sun is dangerous because it's hot. And yes, the sun's visible surface reaches around 10,000 degrees Fahrenheit. That is already incredibly hot. But surprisingly, the surface is not the strangest part. The real mystery lies above it. The sun is surrounded by an outer atmosphere called the Corona. The Corona stretches millions of miles into space. And here is the crazy part. The Corona is much hotter than the sun's surface. Scientists estimate temperatures between 1 and 3 million degrees Fahrenheit. Think about that. Normally, the farther you move away from a heat source, the cooler things become. Stand next to a campfire and take a few steps back. You feel less heat. That is how physics is supposed to work. But the sun breaks that rule. Its outer atmosphere is hundreds of times hotter than the surface below it. For more than 80 years, scientists struggled to explain this mystery. It's known as the coronal heating problem. And solving it became one of the main goals of the Parker Solar Probe. Why this matters to everyone? You might be wondering, why should we care? Because what happens on the sun directly affects life here on Earth. The corona creates something called the solar wind. This is a constant stream of charged particles flowing away from the sun at incredible speeds. When these particles reach Earth, they interact with our planet's magnetic field. Sometimes that is beautiful. They create stunning northern lights. But sometimes it's dangerous. Strong solar storms can damage satellites, disrupt GPS systems, interfere with communications, and even knock out power grids. A major solar storm could affect millions of people. That is why understanding the sun is not just science. It's a protection for modern civilization. The man behind the mission. The Parker Solar Probe was not named after a planet. Yes, a scientist from the past or a famous astronaut. It was named after a living scientist. And that is extremely rare. The spacecraft honors Eugene Parker. Back in 1958, Parker proposed a revolutionary idea. He believed the sun constantly released a stream of particles into space. He called it the solar wind. At first, many scientists rejected the idea. Some even said it violated known physics. But Parker was right. A few years later, spacecraft measurements confirmed his theory. His discovery transformed solar science forever. When NASA launched the mission in 2018, Eugene Parker was there to witness it. At 91 years old, he watched the spacecraft carrying his name begin its historic journey. How do you touch the sun? Now comes the impossible part. How do you build a spacecraft that can survive near the sun? The answer is engineering brilliance. During his closest approach, the Parker Solar Probe faces temperature around 2500 degrees Fahrenheit. That is hot enough to melt many petals. Yet the scientific instruments inside stay close to room temperature. How? Everything depends on a special heat sink. NASA created a thermal protection system made from carbon materials and lightweight carbon foam. The shield is only a few inches thick but incredibly effective. The front side is coated with a special white material that reflects much of the sun's energy. But there is something most people don't know. The sun's corona may be millions of degrees hot, but it's also extremely thin. There are not many particles there. Temperature and heat are not exactly the same thing. The particles are moving incredibly fast, creating very high temperatures. But because there are so few particles, the actual heat transfer remains manageable. That is one reason the Parker Solar Probe can survive. NASA also designed the spacecraft to flex slightly under stress. Instead of resisting extreme forces, parts of the structure bend and adapt. That flexibility helps prevent damage during its high-speed journey. Now, the journey to the Sun. Getting close to the Sun is not as simple as flying straight to orbit. Earth is already moving around the Sun at tremendous speed. A direct flight would not work. NASA needed a clever solution. The answer was Venus. Over 6 years, the Parker Solar Probe performed multiple flybys of Venus. Each flyby used the planet's gravity to slow the spacecraft and tighten its orbit. Think of it like gradually tightening a lasso around the Sun. With every orbit, the spacecraft moved closer and closer and closer until it finally reached its historic Christmas Eve encounter. Christmas Eve 2024. On December 24, 2024, mission controller watched as the Parker Solar Probe enters Sun's corona. Then communication stopped. This blackout was expected. The Sun's intense radiation overwhelmed radio signals. But that did not make waiting any easier. The spacecraft was now only 3.8 million miles from the Sun's surface. The comparison, Mercury never gets closer than about 28 million miles. The Parker Solar Probe was more than 7 times closer than Mercury, and it was traveling at 430,000 miles per hour, faster than anything humans have ever built. For 2 days, nobody knew whether it survived. Then finally, a signal arrived. A simple decoy tone. The message was short but powerful. The spacecraft was alive. Everything was working perfectly. Scientists and engineers celebrated one of the greatest achievements in space exploration history. Now, what the Parker Solar Probe discovered? When the data finally reached Earth, researchers were amazed. For the first time, humanity had a direct view from inside the Sun's atmosphere. The Parker Solar Probe observed how the solar winds form at its source. Scientists watched streams of plasma accelerate away from the Sun in real time. The spacecraft also studied strange magnetic structures called switchbacks. These sudden magnetic reversals appear to play a major role in accelerating solar particles. Many researchers now believe these switchbacks help explain the coronal heating problem. In other words, the Parker Solar Probe may finally be helping solve a mystery that has puzzled scientists for generations. The spacecraft also observed enormous solar eruptions from inside the coronal. Some of the ejected material actually curved back toward the Sun instead of escaping into space. This discovery helps scientists better understand how solar storms develop and evolve. Why this changed everything? The Parker Solar Probe is doing much more than answering scientific questions. Its discoveries could improve space weather forecasting. Today, operators often receive only minutes or hours of warning before a major solar storm reaches Earth. In the future, better forecasting could provide days of advance notice. That extra time could help protect satellites, communications networks, electrical grids, and other critical infrastructure. Considering how much our world depends on technology, that could be one of the most important benefits of this mission. So in conclusion, the Parker Solar Probe achieved something that once seemed impossible. A spacecraft built by human hands entered the atmosphere of a star. It survived. It collected data no one had ever seen before. And it's helping answer questions that scientists have been asking for over 80 years. The Parker Solar Probe is not just one of NASA's greatest engineering achievements. It's proof that humanity can push beyond its limit that once seemed unreachable. And as this incredible mission continues, there is no telling what other secrets of the Sun are waiting to be discovered. If you enjoyed this video, make sure to like, subscribe, and turn on notifications, because the next discovery from NASA might be even more unbelievable than this one.